Let's find our halogens, the H, group 17. And down here I'm going to write most reactive nonmetals. Over here we said they were the most reactive metals. These are the most reactive nonmetals. Okay, let's look at Y. You told me they have 7 valence electrons. Okay, let's draw that. So I'm going to draw, if I look over here, the first one I see is fluorine. So I'm going to draw fluorine. It has an atomic number of 9. Means it has 9 protons and 9 electrons. So 2 in the first level. How many in the second level? If I have to have 9, there must be 7. And I know it's in group 17, so that means it would have 7 valence electrons. So what is it going to do with those 7? Is it going to give away 7 valence electrons, or is it going to try to get 2? It's going to try to gain 2 more. So we call these the takers. They try to take electrons. And it's not that hard to find someone who's willing to give 2. No, not 2, guys. How come you're not correcting me? How many does he need to make it full?
2.
He only needs 1. He has 7, right? They really only need 1. We said they had 7 valence electrons, so they only need 1. Okay, halogens, it says the reactivity in nonmetals increases as the atomic number decreases. So fluorine, this one we drew, is the most reactive nonmetal. And the thing that I thought was interesting, it says halogens react with alkali metals to form salts. So yesterday some students were asking me, well, what does halogen mean? And that made me remember that I think halo means salt. And so halogens are the salt lovers. When they react with the metals, when these here react with anything over here, they form salts. Okay, and that's what it says there. And then group 8 is our noble gases. I'm sorry, group 18 is our noble gases. They are the least reactive elements. So let's come over here. I'm going to turn my paper sideways and write least reactive elements. That's all of these in group 18. That's our noble gases. And they're least reactive because they have 8 valence electrons. That means their outer energy level is full. Okay, y'all told me yesterday they have 8 valence electrons. So if I was going to draw group 18, and I'll draw it here, neon has 10 protons. That means 2 in the first and 8 in the second. So can it fit any more? If it has 8, can it add any? No, it's full. So that's why it says at one time noble gases were considered inert or unable to react chemically. Scientists said, oh, they can't add any electrons. They can't lose any electrons. They're full. They're happy the way they are. They said, I'm satisfied. I don't need any electrons and I don't want to give away any. Because their outer level's full. Now, scientists used to think that they couldn't react chemically at all. But it says in 1962, they produced a compound of xenon and fluorine. And scientists have produced many other substances involving the noble gases since then. In fact, scientists have produced substances that include every noble gas except helium. So they've actually made these noble gases react with other elements. Every single one except for helium. But why are they noble? Why are they special? And why do we still say that they're the least reactive? Because they only form under extreme conditions. Means it doesn't happen very often. Everything has to be perfect. Okay, so it doesn't happen very often, only under extreme conditions. Okay, lesson review. Let's go over your questions now. Which of these is the basis for arranging the elements in the modern periodic table? They're asking you how are they arranged? Okay, I know they're arranged by atomic number. That's not an answer choice, is it? So what is atomic number also equal to? The number of protons. The correct answer is C. Next page. It says the atomic mass of a certain atom is 75 AMU. So my atomic mass is 75. A neutral atom of arsenic has 33 electrons. So if it's neutral, that means its protons are equal to its electrons. So how many protons do I have then? 33. 33 protons. And they're asking me how many neutrons. How do I calculate neutrons? Atomic mass minus protons is equal to neutrons. So if I subtract these two, I would get 42 neutrons. This was something we did last week that could have very easily been on your test on Friday. So that was a review question. Okay, number 3 is the only new question that was on there. This is the only new one. What do elements in the same column have in common? So if they have it in common, we're saying how are they alike? How are they the same? And a column runs up and down, so is that my period or group? Group. If I look here, my groups run up and down. And what do they have in common? The same number of valence electrons. Is that an answer choice? No. So I have to figure out what is the answer then. Does this mean that they have similar chemical properties? If you go and look in your notes, here it told me that groups have the same number of valence electrons, so they have similar chemical properties. So your answer was right there. So yes, that is what that means, because chemical property is reactivity. Valence electrons determine the reactivity. So A is the correct answer. Yes, ma'am. Okay. B says the same number of protons. Well, that's not what it's telling me. C says the same atomic mass. That's not what it's showing me. Same size. We're not really talking about the size of an atom here. So the correct answer was A. And number 4 might have been the easiest question. It says, what are the name and atomic number? Well, I can go over here and look on my front page and I can see that name is here, atomic number is here, or I could just remember this from last week. We've looked at the periodic table plenty, pulling the name and the atomic number. So that the name would be potassium, the atomic number would be 19. Correct answer is C. K is my symbol. 39.098 is my mass. So they were just asking you, what is that tile? What does that element tile tell you? So that was your homework last night. Those were your questions. It was for grade.